Let's, I guess I'll start with Word just so I can type it. Oh, it didn't work. Why did that not work? There it goes. And we'll talk, we've mentioned normalization before. Do you guys remember anything I said about it?
I know it involves, I don't think it's definition, but I know that it involves taking your tables and in some cases breaking them down or
Right. The result of normalization is usually breaking things into smaller and smaller groups. So I'm just going to real quickly go to probably Wikipedia on it. Database normalization. And let's make that bigger. What isn't making it bigger? Make it a little bigger. It just wasn't going very big. So it's basically, it says it's the process of organizing columns, attributes, and tables to reduce data redundancy. I mean, so we were doing a lot of that anyway. I mean, as I said, when we were designing, we were doing some normalization. I'm not sure if I ever mentioned Codd was the inventor of the relational model, and he did the first, introduced the concept of the first normal form. He also did the second and third normal forms. And then there are lots of other normal forms, but we're not going to go through those because generally, when you do the 3 levels of normal forms, your database is workable then. All right. The others are little refinements. And if you're going to become a database professional, it might be worth looking through them. So we're doing the first, second, and third. And then there's like elementary key normal form, voice cod normal form, fourth normal form, essential tuple normal form, fifth normal form, sixth normal form, and domain key normal form. Each one of them adds, as I said, little refinements, but the refinements that generally don't affect a working database that much. And in fact, there is usually a point at which, for production purposes, they do a thing called denormalization. So typically they'll normalize up, I don't know if they'll do everything, but they'll normalize your database, and then they will go through and undo some of that for just processing speed. You know, because by the time you're done, if you go all the way through this, most of your tables consist of a key and one other field about. So you have lots of tables. Yeah.
So, normalization corruption. So when I did a GitHub link for normalization,
Yeah.
it's normalization methods are streamed from a design preventing a party or ward off like database. So whereas the database information you enter eludes repetitive logging. So the normalization faults occur when the data another person enters gives iterating a repeated word information.
So one of the things, I mean, basically one of the goals when you're doing normalization is you want to get rid of any kind of repeated data. You shouldn't repeat anything except the keys, right? The keys should be the only thing that get repeated. There are other things too. You want to get rid of any kind of ambiguity, and there are certain kinds of ambiguities that can result. So there's basically one of the things or some of the things you're trying to get rid of are modification anomalies. And that's update, insert, or delete, right? Those are the 3 kinds. Insert anomalies basically means that you have to insert the same information in more than one place. If you have to do that, you need to get rid of that, right? That's an insertion anomaly. That you have to insert the same thing in more than one place. There's also a type of insertion anomaly where you can't insert into one record because another record is required and you don't have that information. like if you make every new employee, you make it enforced in their database that every new employee or every employee has to be part of a project, right? But you hire somebody new and you have to a project, you can't enter them into the database because they don't have a project yet. That's also an insertion anomaly. Things to avoid.
Is that a rule of thumb of how we want
What do you
to
mean?
build our ERPs and stuff? Should we ask ourselves as we're designing that, is the data going to be repeated twice?
Right, that is a rule. I mean, generally, if it's going to be repeated twice, you want to not. You don't want to repeat it twice, right? Only the keys should be repeated. There is a side effect now. In third normal form, you can have like a customer table with last name, first name, and then an employee table with first name, last name. If you go a little higher on the normalization, you probably want to combine all of those so that all the people and the addresses are in their own tables. And then have separate tables that determine whether they're a customer or an employee. Does that make sense? So I'll show you, but you might have like a people table that has the stuff that's common to everybody, like their last name, first name, email, phone, whatever. If they have multiple addresses, you'll probably have to split out an address table. But the people table, it would be irrelevant whether they were an employee or a customer or a provider. And then you would have an employee table, which would just consist of the key from the people table plus whatever additional information you need for an employee. So, I mean, so that all the people information's in one table, and then, right? So you don't have to repeat the last name, first name, in other tables.
Is that more effective as opposed to where you have a contacts or people table and then like a column that differentiate, like.
Well, I wouldn't put it, actually, probably wouldn't do it as a column. I would do it as a separate table. Okay. You'd have an employee table, and in the employee table, you have just the person, the employee key, the person key, and then whatever other information would be just unique to that employee. So all the information, the name and all of that would just be in the other table. Okay. I'll show. We'll show some examples of this. Update anomalies are similar. Update anomalies, again, are where you have to change data in multiple places. You shouldn't have to ever change data in multiple places. It's interesting when we get to the NoSQL stuff, they ignore all of this, right? NoSQL databases are totally unnormalized. They revel in repeating the same information everywhere. Yeah.
Does that mean that the data is so that you update in place?
Well, it won't. See, the thing is, it won't do that automatically. And you shouldn't have to do that. You should never have to update in more than one place, right? So if a person's address, this is like if the address is all in an address table, and if then the address is only listed once, you should only have to in place, and then from then on, everything will be accurate. If you have to update in multiple places, then you need to redesign it. Deletion anomaly is a little bit weirder. That's basically where if you delete some information, you accidentally lose other information. One example they sometimes give is that if everybody is assigned to a project, and you have an employee who is leaving but was the only person on that project, and you delete the employee row, you might also lose the project information, which is, again, bad design. The project should be separate from the employee. I mean, these are all the results of bad design. I usually spend more time on these, but I won't. I once thought of a detective novel that was based on these anomalies, update anomaly, insertion, and particularly the deletion anomaly. Never wrote it, but I thought about it. And you could have a database as the core of the novel too. So, okay, so I just wanted to show you this is here. Wikipedia isn't bad on this. It's not. So each one of these, if you go and click on the form, it'll go to a thing for that, just that normal form. Right? So if you want more information than I'm going to give you, it's there. And there are other discussions. Wikipedia isn't bad, but there are other ones that you might. Do you guys ever read? This is. Do you ever view the history of the Wikipedia things? They're actually, that's a very interesting because there's a, anybody can edit a Wikipedia article, literally anyone. You have to register with Wikipedia, but other than that, anyone can edit it. And there are huge arguments in the history about what's valid, what's not, what's supported, what's not, you know. I actually think it's a really good model because there is, as I said, there's usually a really robust discussion about most of these topics. Probably one of the bad things about, well, it's not bad, it's just, so Wikipedia has most of the stuff that a regular encyclopedia has, but it has things like its Doctor Who pages must be 60 pages of stuff for that. It's much bigger on pop culture than Doctor Who. Doctor Who. I've been watching it since the 70s, which is all right, let's go back to Word. I'm just going to real quickly give some definitions, and then what we'll do is we'll go through a simple practice where we do normalize the thing. So, first normal form. All right. The basics of first normal form are that there should be no repeated fields within an entity, right? And no arrays, okay? And all the entries in a column or in an attribute, basically, should be of the same kind. Okay, does that make sense to you? That's basically it. So with repeated fields, and we're going to do an example, but it's fairly common. I mean, we talked about like a CD where you have the tracks. So if you had a CD entity, there's a temptation just to do track 1, track 2, track 3, track 4, track 5. That's a repeated field. Anytime you find yourself numbering in a database, that's a no-no. Yeah.
We define arrays as using this context.
I will. Yeah, I was going to do that next. But the repeated fields are really bad idea. Where you're repeating. I'll get to the arrays in a second. If you find yourself saying like track 1, track 2, track 3, that needs to be broken out into its own table. There are lots of problems with that. I've mentioned some of them before. One of them is that if you have a album, so you make 13 tracks because that's about average, right? So you have an album that has 10 tracks, you have 3 empty rows, or columns. You have a album that has 16 tracks and you have no place to put 3 of them. If you want to find one particular track, you have to query 13 fields. It's just a bad idea to do that. So basically, you have to create a track, table. An array is if you were to have one column and you list all of the values. So you have one column called tracks, and you just list all the tracks titles with commas or something separated. That's an array. And what can you see as problems with that in a database? You couldn't search for a single track, right? You couldn't. The only way you could do it is to load it into a program and do string, parsing. So generally, you can't search for individual tracks like that. So basically, what you want is that every value should be a separate row, right? So you don't want to list things separated by commas or something else. That's the array, and you don't want to repeat fields. Okay, both of those, if you find you're doing those, they should be broken off into separate tables. The idea that all entities should be of the same kind, what does that mean to you? Data type, but also, here's an example of what you shouldn't do. It used to be they would give out a spreadsheet with the phone numbers, but they would have, one of the fields was department, department slash, I don't know if they called it person, but the thing is that since both things have phone numbers, you know, they would, some things were person people. That's a no-no, even though they would have the same data type, because they're conceptually different things. Does that make sense? You would want a department table and a person table. They're not. You don't want them together. It's the same data type for sure. There are instances where you might have multiple different data types in the same column, and that's a real problem. So the same data type and also conceptually the same thing. Not that kind of split. Yeah.
Maybe the wrong question, but somehow any table seems to be an array. So
It's different though.
no array.
So let's make, I guess let's do the CD. And I will do the title. So artist, which we'll fix in a moment. Maybe I should get a spreadsheet up, but we'll see. Artist, what else, you know, date, issued or something. We'll do tracks. This would be the thing. And then what would be, so anything else that we would want in there? For each track? Or for the whole album?
It doesn't matter for you.
You know what I can do here? I forget. I'm going to insert table. All right. I'm going to add a couple of things. You might have something like, what do they call like Columbia? Who issues the album? What? I still didn't hear you. Label, that's what I wanted, yes. And then we'll just do tracks. Okay, so I can get rid of these. So let's do title. Anybody have a good title? Actually, I need something I could probably know the tracks to. Or you guys can do them. Any memory I have of an album with tracks is probably going to go back 40 years. So, although I still listen to new stuff. I have kids. Okay, that's actually one I've used before. You have an E in it? I think it does. Oh, I have no idea what the date of that was, like 1968? Actually, I think it came out in 69 because it was the last thing they issued. It wasn't the last thing they...
Let It Be was.
Let It Be was the last thing came out.
But it was after.
Abbey Road was the last thing they did. Right?
Yeah.
Yeah. Okay, so if we do tracks or things like I'm not going to do all of these. I'm just thinking.
It's so heavy.
Yeah, she's so heavy. Which actually is, when I first heard it, I didn't like it so much, but I like it a lot now.
It wasn't for like this repetitive long ending to it.
Yeah, but that's actually kind of hypnotic after a while.
Yeah.
So that's enough. This is what I mean by an array, right? Where they're separated by commas in it. The table is more of a matrix than an array. But, and then if we did another one, it would be, let's just do another album. What?
An array could be a row for a table.
Which one?
It could be, oh, never mind.
Okay. Well, anyway, the trick is this needs to be broken out, right? And into its own table. The other thing is you probably want to do is you want to give, and this is with first normal form, so you want to break out any repetitions, right? Repetitions. And you also want to probably give everything a key. Okay. So we would want to do something like, I'm going to do insert. Well, actually, I'll just do it as a field. So here's another notation for a table. So I'm going to do CDs. And I'll basically just do the fields. So there would be some kind of CD ID or key. That could be a number, or you could do something. I don't think names are pretty unique, but not 100% unique for albums. So you might need to give them something like a thing. And then I would do like artist, artist country, album date, and record label. And that would be it. And then you would have another thing called like tracks as an album, and it would have the track ID, CD ID, although it could get more complicated than this. And then track title, and maybe track length if you really care. And it would be, they would be tied together by the CD ID. Does that make sense? So you break that out. The next two, I mean, the first normal form is pretty simple. You've broken this out. The next ones are a little bit more complicated, and I'm not actually sure this example works that well for the second normal form. So I'll show you something else that I have in a moment. Second normal form, about the at, basically says that you should remove all, and I'm just dependencies. There's a word I'm missing. Let's go here. Let's go back. Not to that. Back. It's still at first normal form. I want to do just normal forms. There we go. Second normal form. Functional dependencies. I was forgetting the word functional. These are things I usually don't forget. I worry about my brain sometimes. Dependencies. Now, what functional dependencies are? Does anybody have a guess before I say? Yeah. Say
Not
it
being
again.
able to put it in the report without having to.
Yeah, or to some extent, what it is if you find in your entity that you have a lot of like sub-themes, uh, groups of attributes that relate to each other but not to other things. Does that make sense? I'm going to give you a different example. I'll post this too. So in Canvas, which I believe I have up in your files, I added a student entity. It's just a picture. And I could try to make that bigger. Maybe I'll download it. Okay, so it's downloaded. Let me bring it up. Let's open it. Let's see if I can make it big. And make this bigger. I don't know if I want to maximize. And then make it bigger. Okay. So this is like a student thing, and I put it there so we could do it. So we have like major 1, major 2. So that's first normal form. It needs to go away, right? And we have, that's probably all the repetitions, those two. There's a couple of things that are plural, like I think course numbers and course grade points. Those would need to be broken out because they're essentially going to be arrays when they're plural. Does that make sense? So those are first normal form. If you want, we could design this one in a moment. What sub-themes do you see in here? So this is supposed to be about students. Yeah.
Department.
Right, so department is a kind of notice all these things are related: department, department phone, department building, department room. All of those things relate to each other, but they're not really relevant. They're relevant, but they're not related to student. Does that make sense? So that would be a functional dependency. That means that there's a subgroup in here that needs to be moved into its own. Right? Again, when you're dealing with data that comes from spreadsheets and stuff, this is fairly common. But you need to break it up. Every entity should be about one thing. So this entity, since it's named student, should be about nothing but student information, right? Now, again, students do have some relation to departments, but departments is a different theme. Yeah.
So you then break out the thing. I mean, I know the advisor relates to the student, but you have their name, but it's not necessarily you need to know their phone number related to the student. But you break that out as its own.
Right. So this is sort of another little sub-thing thing, right? So that's probably needs to be broken out too as advisor. It's also, so here's a question as to whether it is, let me go back real quickly to this. So this is big themes, right? There is another, the third normal form is a little bit more subtle. And then what I'll do is we'll break up that student one and we'll make it into a diagram. And then we'll call it good and let you guys work on things. This won't be our only touch on this. When we go to our next database, we'll kind of repeat some of these things and try to refine them a little bit. Just to let you know. Third normal form is about removing transient dependencies. These are a little bit more subtle. You could argue that advisor and advisor phone is one of those. One of them I did on purpose here is when you look at the CD on artist, first of all, artist could be plural, right? So that's actually probably should be broken out right away. Because there's a lot of compilation albums out there. So artist could be plural, so that should be broken out for that reason. But even if you were to leave it, artist country doesn't actually identify the CD or the album. It's actually talking about the artist, right? So it's not anything that is not describing what the key is. Anything that's not describing CD should not be in that table. And artist country is describing artist, not CD. That's what's called a transient dependent. The only difference between a transient dependency and a functional dependency is that a transient dependency is more subtle. It's usually just like one field, whereas a functional dependency is usually a group of fields. Does that make sense? But in both cases, they need to be removed into their own table. So artist should be removed from here into its own table. Does that make sense? I have a PowerPoint on this, which you might want to look at if it doesn't make sense, because I'm not 100% sure on how clear I'm being today. This stuff is complicated, but let's take that student thing and use Visio to make a diagram, and then we'll call it good. We could also do it with the CDs if you want, but I don't know how many Visios you want to make. I swear I activated. I don't want to activate by next. It better not take several moments. But I can do it in the background, so I won't do it. Okay, it activated. Do you guys have to activate it, or is it just because mine updated? So I'm going to do crow's foot. I will make it a little bit bigger. So I'm going to bring in an entity, and we'll call it student. And what we had in our original student, so let's look at that picture. Should have saved it as a Visio so I didn't have to go back and forth. Which things relate directly to the student? Name, birthday, email. Probably years enrolled.
Advisor name or do.
So that's depending, and that actually depends on a kind of a business rule. Does everybody have one advisor only, or can they have multiple advisors over time? You know, things like that. I probably would leave the advisor out right now, but it could be in there. It depends on how you define it.
And course grade points.
I wouldn't put them there because it's going to be an array. It's multiple values, same with course numbers. Basically, you've got, let's go back, name, birth date, email, probably years enrolled, right? So we'll do a student. Do you like key or ID? Guess we can do ID. Student name. And student birth date. I'm just going to drag an attribute over here. Student years enrolled. I have questions about that, but we'll worry about that later. Anything else that belonged to the student that I'm missing? Oh, student email. So let's drag that over. One of the things I may not have mentioned, I'm going to design and choose a, It doesn't matter what order the attributes are in. One of the rules of a relational database is that it absolutely doesn't matter what order the attributes are in, and it also doesn't matter what order the rows are in. All right, so you don't have to, some people are really hate it if you put old information and then new and then old, and it doesn't matter. So the order of the rows and the order of the attributes is irrelevant. You can sort and arrange them any way you want in a query. All right, so that's it. The other thing we said that we really needed, not an attribute, but an entity, was department. And so we'll do a department key. What else was in there for the department? Let's look at it real quickly. Phone, building, and room. Building. Doesn't matter, but I'll do building first. Okay. We had advisor. I'm going to keep dragging attributes when I want entities. We'll make it a separate thing. And then we'll talk about how you relate all of these. So we have, let's give it an advisor key or ID. Advisor name. Phone. Now with the here's an advisor is probably an advisor only for one department, or do you think? Here they aren't. Here they've been shipped all the time. If they are, you could just put the department key in here. If not, we're going to need a linking table. I guess we'll do it that way. Let's get the other stuff that's in here. So we got advisor, the major. They could have one major or two majors, and majors probably belong to departments, right? So I'm going to bring one over here. I'm going to say major. Major, we'll just give it a key, whatever that is. When we actually make decisions, is what the major name. You might describe, I mean, actually, if you were way out, you'd probably have a bunch of courses, which we may want to do, which relate to the major, right? And then I think actually majors are usually department specific. So I'm going to put the key in here, and we'll do the relation to that, the foreign key, and add it as a foreign key. Because majors usually belong to a department. What else do we have? We have the course and going back to the picture. Basically, we have the course numbers and the grade points. So I probably would do a course. Course, I guess the number, and we could do like course name. Well, so it could be a course number, or if you're doing auto numbers, I mean, we could just do a course key. Do you want to do it that way to be consistent? And this, so this would be course number, and maybe course name. And I will, though we don't necessarily need to be, I'll also add credits. So this is, in the normalization process, we broke all of this stuff up. So from one table, we ended up with 5. But when we actually start making the relationships, we're going to even end up with more, right? So if an advisor can, I'm just thinking of where to start on this. If an advisor can be with multiple departments, then what do we need to do? Yeah, linking tables. So what we want to do is, I'm going to do advisor department. I tend to just put the two names together. And I would probably do advisor key, department key. Get rid of the last one. I'll drag this up here. I'm going to make it a primary key. And to do the relationships, shoot. I will post this too. So I'm going to, and let me make these big. One, any, and one advisor. So let me copy this. One advisor. I want to get to the whole, there we go, can be part of many departments. Does that look okay? All right. Now, one student could be advisors too, right? We decided, or do you want to just make it into just one advisor? If we have many, then we need an in-between table. Student advisor. And I'm just going to do student. Actually, I'm going to just give this a student advisor key. Advisor key, student key. And maybe give it another attribute for how would we want to do it? Because I think if we'd want to know what dates. Do we want it as dates or as year, term? Term. I don't want an array of terms, but I don't want to make another table necessarily right now.
Start term, end term?
That would work probably. I should do student advisor start term. If I'm going to do that, I'm trying to be consistent, although it gets very big. I need to move things around, obviously. Let me move this over. I don't have to be on one page. All right, so we got student advisor. So the student ID, again, if we do One student can have many advisors, and one advisor obviously can have many students. I think I would go from the advisor down here and then up here. Okay, so that combines students and advisors. So if we have majors, this is going to be a mess though, because I need to connect this to this. Also, I haven't done the foreign keys here. If you want, I mean, I've done them, but I haven't labeled them. Which can be useful when you're designing. It can be useful to see that. Okay. I'm trying to think of how I want to move things around. Bear with me. Oh, that makes a mess. As I said, these things get cranky here. I want department down here because I need to, like as I said, mix department and major. I'm just trying to move things around so they make sense. And when you make your own designs, you may want to do that too. And and I was doing so major from department, and I think I'm going to move. Well, we need a student major and student major, right? I spelled department wrong. Doesn't matter a whole lot, but all right, so student could have more than one major. So that would be a linking table. And I'm going to call it student major. Now you could, if you limit the number of, so I'm going to do student ID we did, and then major key. Get rid of this one. I'm going to move this up there, make them and then we'll do the relationships. One department can be part of, actually I don't need department there. One major can be each major can be majored in many times. I lost the line. Yeah, I know, I hate these too. There's probably a better way to do it. If anyone finds it, let me know.
Is there any way to shrink the boxes? I'm having trouble.
You know, you can shrink the zoom. I can shrink the zoom. I don't know if I can shrink the actual boxes. I could probably change each student can have multiple majors. All right. When you have the courses would belong to a department. So I could probably just put the department key in there. I will show you all of this. The point of this is just to show you how far it goes from one table. And then I'll try to put it up in a way you can see it all. There's also a relationship between course and major if we want, like what courses belong to what major. And it's a multiple thing because one course could belong to multiple majors, but I think what I will do is not do that right now. That adds another thing, but we need student and course, right? We need the student and course to get together. So I'm going to, I'll just call it right now student course. And we would need the student, I'm going to call it student course key. The reason when I don't do the double key like the normal linking table is if there's going to be other stuff in it. Because this is going to have the student key, the course key, and the other thing that we had was their grade, right? That's the only other thing left in that student table that we haven't accounted for. So I'm going to say student course grade. So this will be the grade that they get for that course. Student key would be a foreign key. Course key is a foreign key. So one many students, and each student can take many courses. So I'm going all the way back up to, is that major? Yep, I need to go all the way up to student and come down here to course. Yeah.
Should we call it student key or student ID?
We probably should call it student ID. It actually doesn't, they don't have to thing, but it helps if they are. Say again.
It reminds me of connecting them, it reminds me of the server routing.
Well, it actually, so you could probably, I mean,
I don't know, I was just thinking out loud.
Yeah, I can't see
That's all I
any
was saying.
connections.
yeah, I'm going to try. Actually, that's not what I wanted. I'm going to try to put it all up there. I do not know how, see, it's not, so I could shrink it a little bit. But what I was going to try to do was to put it all up. Can you see it well enough to see the things there? It's a little bit complicated, and again, as I said, the main point of this is just to say we had that one student table. When we've normalized it, we end up with something like that. Right, so again, remembering the specific rules is not super crucial. It's just that you don't want any reference, you don't want any ways, you don't want any subgroups, right? So if you start to break these things apart and then make the relations between them, it gets, one table ends up with 1, 2, 3, 4, 5, 6, 7, 8, 9, and could actually have some more if we get courses and majors. I will post this. I'll post it as a video and as a picture. Okay. And we still got some cross things going on here. I think this is coming down here. Where's the other word? What else is clicking here?
But you don't need the corners, the corner one right there.
Which one?
On the right, so the advisor in the department, you have the advisor in the department connected, so on the right side, there's a corner,
Oh, right.
but you don't need the connection.
Yeah, advisor and department should, because they're connected up here.
Yeah.
But I think what's happening here is this is coming behind that one. Let me see if I can move it. So advisor goes to department. I think this got mixed. So one department, this should go up. That's advisor. This should go up to department. I should be able to do these. So one advisor, this goes from one to many, and department should go from one to many. And what is happening with this cross in here is it's a one on top of a many. They're sharing the same point, which drives me nuts. I want them to move, but I don't know how to make it move. I think actually most things are working other than that. Whoa, okay. Huh. Don't you hate how it jumps?
Yeah.
If I move that down there, it still does it. It still has this cross here. Anyway, as I said, the main point is just that it's broken up a lot. When you draw your own ones, I'll try to figure out all the relationships. What I'm mostly interested in when you do your own design is that the one side is on the proper side and the mini side is on the proper side. So one over here, mini, that actually matters when you design, when you actually build the database. If you get your relations backwards, you won't be able to enter data. It won't let you do the data. So, but it'll let you make the relation backwards. It won't complain about that at all. But then when you try to enter data, you won't be able. Questions about that? I mean, that's fairly complicated. We went through there. Again, the three normalizations that we talked about, just no repetitions or arrays. So nothing that has a whole list of things. Separate topics need to be broken out. That's sort of all three of them put together into two big principles. As I said, I will post this. And I will post it both as, in the blog, I'll post it as a picture, but I'll also post the PDF, the Visio file up in Canvas. So if you want to download it and play with it, you can. Looks like most of you have it pretty well. The relationships are a bit weird, just weird to draw. They're not necessarily weird. Other questions? Did this make any sense?
Yes.
Okay. Why don't we give it like a 5-minute break or so, and then you can work with your groups to start designing Vince's vinyl. Couple of things about that in your groups. If your first design isn't perfect, it's not a big deal. Part of what we'll do is we'll get feedback on the design and you'll have a chance to improve it. So do the best you can, and then we can, refine them as we go. So don't panic if
We can learn our first draft.
So let's look at.
Remember.
I think what I did is upload it if you want, but then present it like we did with the discussion of the fields. So you present it, and then everybody will have a chance to weigh in on what they like or don't like about it, which is fine. And it's also possible that they can vary a little bit depending on how you decide if the business rules should be interpreted. So they don't all have to be the same, but you can look at them and say, what did you mean by that? you know, is that, did you think about this? You know, just make sure that everything is thought about and considered. And then, as I said, you can take or leave discussion as you think fit. I might weigh in on a couple of things. And then the next step after the review is to upload a revised one if you need to. I mean, if people thought it was perfect, you can just upload the same one. But if not, you can upload a revised one. And then we will actually build the database. We'll build it in SQL Server, and I'll show you how to download the virtual machines for that. Probably next week, because I assume you'll need most of Thursday to work on this. Or, yeah, Thursday. Today, well, what is today? Today's Wednesday, so Monday, I guess. I'll give you an hour now, but I'll probably give you most of Monday to work on it, depending on where you guys seem to be. This should take some time. I mean, at least you should try to take some time doing it. And it can't, it's a little complicated, as I say. All right. So as I said, you can have a break and then you can do, start working on this in your groups. I will post this right now. I'm going to turn off the overhead though, unless you need it.
I have a question.
Sure. Sure.
There's simple, if I were to add a little box to this, I just have to.
So, and after you, is that what you want, another volume or another full bar? That's right. You might have to move
That's a
things
huge,
over.
no, oh no.
Oh, that's not.
Okay. Yeah, pretty much.
Yeah, we'll make one of these.
Okay, and then if I wanted to,
And then
am I
we
using the
stand up
same
and
lens
present
as
it.
you, yeah?
Yeah.
They're not legit.
So I can do it bigger.
The Vinci,
Right, so what I did is I clicked on the line. Right, because show that shit over
And
here.
that's a good question, I don't know.
Then
I think we just work on it together in class. And have one file that we have.
You can make them whatever, so they're readable for
The beginning,
the beginning.
We make one file.
See.
and I can change the color of it.
You can change, yeah, now the way to change.
I just used this to change the color of the words last time.
Yeah, you can also do this on.
Yeah.
So I think this line is always different.
Oh, you don't need that, we're gonna work in class off the notes, no.
Okay, that's sweet, okay, thanks.
Okay.
I wanna make sure I explain the right thing, and we're working on this just in class because.
Yes,
Okay,
working on, I mean, for the group stuff.
Yeah.
I will give you quite a bit of class time to do it. If you want to work out of class, you can. But,
I don't think any of us have it.
yeah. There we go. Yeah, I intend to give you quite a bit of class time to work on it, as I said. So if you want to do things out of class, you can. Although, as I said, if you don't have Visio, you can hand draw this stuff. I mean, and then translate it to Visio or some other program if you want. But you don't have to work out of class. Unless, like, Monday isn't enough time. You know.
So Monday we make a one file and Wednesday we present.
Ideally, but we'll see where people are. I don't look at the right timeline I put into the canvas to remember.
I got Canvas up. Yeah, you have presentation for the 17th.
Which Wednesday? Or is it after that?
It's the 12th, so that you've got to still got a label for Monday.
The
The
presentation.
on Monday.
Well, I think it'll be more likely to be Wednesday. I can't believe I thought unless everybody does amazing in the next 45 minutes.
So we make one file and
So in Canvas, it says the presentations are Monday, but it'll probably be more likely Wednesday.
Okay. The track table, and we were talking about eliminating the CP table. I think I still think it's gonna be a good scrape box on the website and we'll get on board because sometimes you don't have an internet connection, have to go down someplace. That's just me though, I try not to assume you're always online. I've had too many. Yeah. And then you can see the content problem. Let me pull up. Pull up our notes.
Okay, so.